Hello guys, how are you all doing? So, I'm Shruti Reddy and I'll be teaching you all guys class 9th and 10th science. So, we are starting with first class ninth physics, then we will move on to class ninth chemistry, then bio. Similarly, 10th also will be covering this way. So, class ninth and 10th, your science is sorted, as well as I'll be providing you your foundation for JE as well as NEET examination. Foundation, all kinds of concepts, introduction, I'll be giving you all guys. And if you all guys are even more interested, then we will be moving on to complete course. I'll design foundation course of JE and NEET for you all here. But now we are along with your lectures, few topics, extra topics related to a higher level concept, higher level thinking concepts we will be covering, and questions will be covering in my lectures. So we are starting with motion chapter, and this is the very first lecture. So how did I design this course? I will be explaining you quickly. First we'll be learning concepts, basic concepts, which is of grade of your grade, okay, like of ninth and 10th level. That basic concepts we'll be learning. NCERT full definitions will be covered. Complete NCERT is covered here. You need not, after this, if you read NCERT textbook, you'll be able to understand each and every point. That is my guarantee. Okay. So after this, so complete NCERT ninth and 10th level will be covering. After that, I will be giving you an extra section where that is called as level up concepts. That is purely level up content. Whoever wants to continue to that content, they can continue the video, or they can just stop by after watching 9th and 10th level video. Okay, so that will be included in one video only. So first we will be going with the class 9th and 10th level content, NCERT content. Then we will be going with the level up content. The level up content, this will be a foundation for your JE and NEET examinations, competitive examination. Even if you're aiming for any other examinations like ICER, aptitude test, NEST exam, basically these are the exams for research. And if you want to get into research field, these are the exams. And yeah, so for these exams also, this is the foundation. Okay, then after this level up concept, we will be going with the questions. A few questions we'll be doing here, and every day as a DPP, or the daily practice problem questions, I'll be attaching a PDF along with this video. You will be solving those questions. So this way you will be mastering your 9th and 10th concepts, as well as you'll be having a foundation for your JE and NEET, so that if you enter class 11th and 12th, everything seems easier for you. Or because many students suffer a lot, not able to bear the load of the syllabus or the concept clarity in during the transition from 10th to 11th. So this transition will be easier for you if you follow my video lectures, because I'll be giving you the foundation and of science, basically of physics, chemistry, bio. Foundation will be crystal clear for you all guys. So follow these lectures obediently and follow the question series and NCERT. More than enough for your boards and for you, as well as a foundation for your JE and NEET. So yeah, if you want even more level up content, comment in the comment section. I will be creating videos on that as well, like literally teaching you all guys 11th and 12th content in the 10th itself. If you want that kind level, or that level also, we will be doing it. But for now, we will be doing a little level up from your present grade, so that when you enter your higher classes of 11th and 12th, you won't feel difficult at all. Okay, so let's start. So this was about the introduction. Quickly I introduced you how this course is designed for you all. Okay, 5 minutes it took. So let's start with the chapter now. So we will be doing distance and displacement from concept from the motion chapter in this video. So let us start. Now motion. Now what is motion here? Okay, what is motion here? See, motion basically means movement. Okay, like movement. Motion is what? Movement. So this notes and all, you can copy it right now, or I will try to attach this PDF of the notes. Okay, most probably you can copy it simultaneously, so that it will be like interactive school kind of session. Okay, so you can note it down simultaneously. So on this sheet I'll be explaining you the concept. This will be your notes. Okay, first don't focus on notes, just focus on what I'm telling you and what I'm scribbling on this sheet, so that after that later I'll be showing this notes part, you can note it down simultaneously. Okay, so okay, yeah. Now what is motion here? See here, the motion is the movement of a body or object is called motion. Now, this is a basic definition. What do you mean by motion? What do you mean by, I hope, yeah, okay. What do you mean by motion? Motion is basically movement. Movement is nothing but motion. This is a basic concept. Movement is motion, right? So, movement means if a person is walking, he's in under motion. Okay, now if this is a train, to this person who is watching from outside, he will see, let us say it's moving with some constant speed. Okay, let's say it's moving with some constant speed train, and there is another person sitting over here. Okay, there's another person sitting over here. Okay, now for let's say this is A person, this is B person. For A person, this train is moving with a constant speed v, and this person B is moving with a constant speed v. Okay, but in which direction? In this direction. All right, but for this person B, he will consider himself as rest. Okay, he will consider himself to be at rest, and he observes that this person A is moving backwards with a speed v. Like whatever speed he is moving forward, this B person will see A person moving backwards. Are you understanding? Like this train is moving forward. Okay, like always we will consider the reference to be at rest. Okay, now reference is the person who is viewing. Now who is viewing here? Suppose I am considering B to be viewing. B is viewing whom? A. B is watching whom? A. So if B is watching A, B will consider itself at rest, which means that B, if he is moving forward, he will see A moving backwards, because he is considering himself as rest. Okay, but A will be viewing B moving forward. So always you can, from this you can conclude that motion is a relative term. Motion is a relative term. What is motion? Motion is a relative term. Now motion is a relative term because it is depending on the frame, it is depending on the person viewing. If A is viewing B to be moving forward, while B is viewing A to be moving backwards. Okay, and always remember that the reference point is a person who is viewing, that he will consider itself to be at rest. It will always consider itself to be at rest. Always a reference point will consider itself to be at rest, and with respect to that it will view the object. Okay, now you're able to understand, right? Motion, exactly, motion is movement, and this movement depends on the person who is viewing. Okay, like now for this B person, this train is at rest because both of them are because it is inside, and this or else we'll just consider one more thing. Let's consider another person C here. Now for B person, C is at rest, right? For B person, C is at rest, but for A person, C is moving with a constant speed v. Okay, from this instant only you can understand that motion is a relative term. It depends on the reference point, and reference point always consider itself to be at rest. Okay, these are few important points which is very much basic even for your competitive exams like JEE and NEET, but for 10th class level also, if you have this much concept clarity, you can solve any kind of questions. Okay, so this was about basic introduction of motion. Let us see what the notes part now. What is motion? The movement of a body or object is called motion. Basic movement. Basic movement is called motion. A common characteristic of all moving bodies is that they change their position with time. Yes, motion means changing of position with respect to time. All right. We can, if a person is not changing its position with respect to time, it means that the person is at rest. Okay. So changing position with respect to time is called motion. Now, what is reference point? Reference point, as I told you, it is a stationary object, means a person who is viewing. Okay. Person or object viewing another object. It will consider itself to be at rest. It will consider this will consider itself to be at rest. Okay. Next, is motion a relative term? Now they're asking here, is that, is motion a relative term? Yes, motion is a relative term, and I explained you why motion is a relative term. Okay, so this is clear now, right? So let's move on to distance and displacement topic now. Now, motion, now see, what is the simplest form of motion? First, you need to know that. Now, simplest form of motion is motion in a straight line. Here, yeah. So, simplest form of motion is motion in a straight line. Is motion in a straight line. Motion in a straight line. So simplest form of motion is motion in a straight line. Okay. Motion in a straight line is the simplest form of motion. Now, why motion in a straight line is simplest form of motion? Now, first of all, let me move with an example here. So, okay, no, see here carefully, the screen you see carefully. Let's consider this to be point A, this to be point B, this to be point C. Let us say this is 10 kilometer, this is 20 kilometer. Okay. Now, before we move with this example, I will give clarity about scalar and vector quantity. Now, what is a vector quantity and what is a scalar quantity? Vector quantity is the quantity which has both magnitude and direction. Now, what do I mean by magnitude and direction? And what is scalar quantity? Scalar quantity is only direction, is only having magnitude and no direction. So, what do you mean by this magnitude, direction? I will explain you now. Okay. Suppose this is a point A, this is point B. We will be giving the scalar and vector quantity definition by first explaining you the concept of distance and displacement. Alright. Now this is point A, this is point B. Now I have taken here 4 paths. This is path 1, path 2, path 3, path 4. Like 4 paths I have considered here. Now, if you see here, if I take path 1 like this, and if I see path 2 like this, are both these paths same? No, path is not the same, right? And if you see the amount of length, the length covered here is different as compared to the length covered here, isn't it? So, if you see here, there is no specific direction this is following. This is just a path. It is just randomly moving. It is not following any specific direction here. So this is what the length, the length of this path, that is called as magnitude. The amount or the length that is followed from A to B, this is magnitude. Alright, so we were discussing here. So the magnitude of this path, like the total, the amount of this path, the amount that is there, that amount is called as magnitude. For example, let us say this path 1 is about 20 kilometer, let's say, and path 2 is about 10 kilometer, let's say. Now this 20 and 10 kilometer, this is called as magnitude. Are you getting the point? This 20 kilometer and this 10 kilometer is called the magnitude. Now, So what is a distance here? Distance is basically total path length covered, and it does not depend on direction followed. Yeah, simply any path length, like you can choose any path, so that is called as distance. So distance is basically total path length covered. It does not depend on the direction, only depends on the magnitude. Are you getting the point? So this is nothing but scalar quantity. So distance comes under where? It comes under scalar quantity. I hope magnitude and direction concept is getting clear. Now direction concept, we will see what do I mean by direction. Now see here. First of all, if you see here, the shortest path, like the shortest path here between A and B is path 4. It is a straight line. For example, let us say here, um, let us say your house is over here. Let's say your house is over here, and another house is over here, your friend's house. This is your house, your house, this is your house, this is your friend's house. Now the only path that that connects your friend and this path is this road. Like first you go from here, there's a road from here, then there's a road like this, then again there's a road like this, there's a road like this, and like this. Okay, so if you want to reach your friend's house from here to here, you need to follow this path. Okay, this is a road, and this total path length from here to here, this is known as distance. Let's say this is 10 kilometer, this is 10, this is 10, this is 10, this is 10. Let's say what is the total amount of distance covered then? 10 plus 10, 20, 30, 40, 50. 50 kilometer is the total distance traveled here. Now what is the shortest point that is covering these two? This is the shortest point. And what is the direction here? Now if you want to go from here to here, the direction, the arrow will be shown like this. If you're going from here to, if you're going from your house to friend's house, this is the initial point, this is the final point. So the direction, the arrow will be shown like this. So this is called as displacement. Displacement is basically the shortest path between the initial and the final point, and the direction that you show will be from the initial point to the final point. Are you getting the point? So this is basically an imaginary path which is not possible. Okay, it may be possible, it may not be possible to travel. Okay, but the actual path length is what? Actual path length is basically the distance. Shortest path followed between initial and final point. Shortest path followed between initial and final point, and direction is from initial to final point, This is called as what? This is called as displacement. I hope now direction, now see, displacement has a direction also here, proper direction from the initial to final point is a direction, and then the shortest path length, that is a magnitude. So that is why displacement will come under vector quantity. So vector quantity has both magnitude and direction. Scalar quantity has only magnitude and no direction. I hope you understood why vector quantity has both magnitude and direction, while the scalar quantity does not have direction and only magnitude. This magnitude and direction concept is clear, I hope. So here under vector quantity I have here displacement. So this is the thing. So here we have definition here. Let's read the definition quickly. Shortest path length followed between 2 points. Those one of the point is the initial point, the other point is the final point. Depends on both magnitude and direction, does not depend on the path followed. Direction is from the initial to the final point. Now from here, from this example, you can see that distance of path 1, path 2, path 3 and path 4 is different. Distance is different. This could be 10 kilometers, this could be 20 kilometers, this could be 30 this could be 5 kilometer, and this could be 30 kilometer. But if you see displacement of path 1, path 2 and path 3, path 4 are same, because that is basically the shortest path between the initial and final point. Here path 4 will be the displacement, because this is the shortest path. Shortest path between 2 points is what? Displacement. And the direction is directed from the initial point to the final point. I'm considering A to be the initial point and B to be the final point. Okay, so displacement of path 1, path 2, path 3, path 4 is the same. Distance of path 1, path 2, path 3, path 4 is different here. Are you getting the point? Now another thing is that can the magnitude of distance be equal to displacement? Yes, it can be equal. But in what instance? In only fourth path. In fourth path, if you see here, distance and displacement are equal. In path 4, I hope the numbers are you are able to see. Let me just name the numbers again. 1, 2, 3, 4 path. Okay, so in path 4, if you see, distance and displacement is equal. Distance and displacement is equal. But if you take path 1, for path 1 displacement is this 5 kilometer, distance is 20 kilometer. For path 1 is distance and displacement equal? No. In path 1, distance greater than displacement. So in path 3 also, this is the distance in path 3. What is the displacement? 5 kilometer is the displacement and 30 kilometer is the distance. Okay, so 30 kilometer is the distance. So here also distance greater than displacement in path 3. In path 2 also same. See, this is 10 kilometer, this is the distance, displacement is 5 kilometers. So this is going to be here again distance greater than displacement. So from here I can conclude that displacement is less than or equal to distance, and this is always. So displacement is less than or equal to distance. Okay, basically magnitude wise, this is a symbol for magnitude. Okay, so magnitude wise displacement is always less than or equal to distance. Okay, so now the question here is can the magnitude of distance be equal to displacement? Yes, only in the straight line motion, if without changing direction. If the direction is not changing, then only the magnitude of distance is equal to the displacement. Okay, without changing direction. This is important. Okay, now one more question arises. I'm writing here. Can displacement or distance be equal to 0? Can we equate distance or displacement to 0? Can we equate it? See here, one thing you have to remember is, I'll give you an example. You will be able to answer it on your own. This is point A. This is point B. This is point C. Okay. Now, a person travels from point A to point B 10 kilometers. From point B to point C 20 kilometers, let's say. And he travels back to A 30 kilometers. What is the total displacement here? What is the initial point? Always for displacement, you need to consider initial and final point. Initial point is what? A. Final point is also A. Then what is the displacement? 0. Getting the point? Now distance. Calculate distance now. So for what did I tell you? First he moved from A to B. A to B is how much? 10 kilometers. Then he moved from B to C. What is B to C? B to C is 20 kilometers. Then he moved from C back to A. 30 kilometers. How much did he travel total? 30 plus 30. 60 kilometers. Getting the point? Basically direction. Distance is not depending on direction. Okay. Distance is not depending on direction. Distance is depending on the total path length. What is the total path length? First he moved from A to B, B to C, back to A. This is the total path length. First he moved 30 kilometers from A to C. Then he moved from C to A back. So that is 30 kilometers again. So 60 kilometers total he traveled. Understood? This is the distance and this is the displacement. So displacement can be equal to 0. Distance, but distance can never be equal to 0 if it has traveled some amount already. Okay, like if you say from A to B, if it has traveled, distance can never be 0. But in the initial point, if it is at rest initially, then distance is 0. But if it has already traveled some point and it has come to rest there, distance is not equal to 0. Are you getting the point here? Okay, so this is how you understand the concept of distance and displacement. So we will discuss some more points. So I hope whatever points I have explained you so far is simple. Let's move on to the next points of distance and displacement. Now look into the level up concept of distance and displacement over here. Now distance can never be negative. Displacement can be positive, negative or 0. Now if you tell me how can displacement be positive, negative or 0, I'll explain you now. This is the level up concept again. If any student is not comfortable with this, you can skip, not an issue. This is not for your 10th level. If this is a foundation, as I told you. But if you, it is very simple, okay, not very complicated also. I haven't taken so much deep concepts. I have taken simple concepts and to make you feel better. Now see here, how can displacement be negative and distance can never be negative. Okay, let us say I have taken, this is A point. Let's say this is the origin. Okay, this is the origin. First I moved from in the positive axis, I have moved 10 kilometers. Okay, positive axis to B point. Then from B point I have moved to C point. This total length, let's say 30 kilometers. Then what will be this point? This will be 20 kilometers. Now I want you all guys to find out the distance traveled. Distance is how much? First he moved 10 kilometers here. 10 plus 30. How much total? 40 kilometers. Total path followed. That is the distance. Now if you see displacement here, first 10 kilometer it has moved here. Again it has come back to a 10. So displacement here is 0. Now it has moved minus 20 kilometers here. Like direction, if you see, it has moved from, if we consider this as the origin, we know that displacement has both magnitude and direction. So this has moved, this minus or plus here in vector quantities is basically denoting the directions. Okay, that is denoting the directions. Now it is moving in the negative x-axis. I'm taking this as x-axis. Okay, let's consider this as x-axis. We need to consider an axis if we are considering the what do we say, origin. So if you see here, first it has moved from A to B and back to A. So displacement at this point is 0. Now again it has moved 20 kilometers towards the negative axis. So that will be minus 20 kilometers then. So what will be the displacement? What will be the displacement? Displacement will be minus 20 kilometers. Getting the point here? So it has moved 20 kilometers extra in the negative axis. Okay, so this negative sign is basically what? This negative sign is basically the direction. Okay, it's a direction, it is a direction. So what is its final position? Final position, basically what did I tell you? It is the shortest path between the initial and final point. So what is the initial point? Initial point is A, final point is B. And if you see here, it is this is the origin and it is in the negative axis. The final point is in the negative axis. How much it is in the negative axis? By 20. So minus 20 will be the displacement. Have you got the point here? So that is why displacement can be positive, negative or zero, but distance can never be negative. And you know, it is a scalar quantity. This is also a vector quantity. Now this is not affected by the shift of position of the origin of the coordinate axis. It depends on the position of origin and is affected by the now what do I exactly mean by this? I'll just explain you here. Now suppose this is point A, this is point B. Okay, so if I view from here, if I view from here, or if I view from here, from anywhere, if I view the shortest path, if I take with respect to this person, if I want to move from A to B, this is the length of the path. With respect to this person, if I want to move from A to B, this will be the length of the path. With respect to this person, if I want to move from A to B, this will be the path. But if you see here, shortest path between both of these is always fixed. Shortest path, the shortest path between the initial and final point is always fixed. But relative to this person, the path is different. Are you getting the point? Distance is different from with respect to this person. The path that they have to follow so that they move from A to B, that is different. But the shortest path, the displacement that is there between point A and point B, that is always fixed. So if you see here, coordinate axis or the origin dependent is the distance, but displacement is always fixed. It okay, irrespective of the origin, irrespective of the coordinate axis, displacement is always fixed between point A and point B, between the initial and the final position. But distance is varying with respect to this person, 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 because the path that this person should follow is different. The path that this person should follow is different. The path that this person should follow is different. Are you getting the point here? Okay. So that is what these 2 points mean. Okay. And this cannot decrease with time. Okay. It always increases with time. Now you have always, you already saw, if a person wants to move from A to B, B to C, okay, or come back to A also, distance is always increasing. Okay, but if you see displacement, it has decreased. It can decrease with time. See, if you see the total path that the distance between A to C is how much. First he moved from A to B, 10 kilometers, then 30 kilometers. So total how much? 40 kilometers it has moved. But if you see displacement here from A to C, it is less, because this is the shortest path between the initial and the final point. It is minus 20 here. So if you see here, 20 is less than how much? 40. So we can tell that the displacement can decrease with time. Distance cannot decrease with time. So the same thing that I have written here. Distance, magnitude of distance is greater than equal to magnitude of displacement. Now we have few questions here. Let's solve these questions. Then we will end this video. Okay. A farmer moves along the boundary of a square field of 10 meters. So let's draw the square field here. 10, 10, 10, 10. Okay. In 40 seconds. So he moves in the boundary of a square field of side 10 meters in 40 seconds, which means he moved how much? 40 meters he moved in 40 seconds. Okay, what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position. Let's say this is the initial position A. From his initial position, what will be the displacement we need to find out? So 40 meters he has traveled in 40 seconds. This is clear for us. Okay. Now we need to find out displacement. First of all, we need to find out the position at 2 minutes 20 seconds. I have told you initial position is known. Always for finding displacement, we need position. So first, at the end of 2 minutes 20 seconds, what is its position we need to find out. Now how will we find out the position? First of all, 40 meters it has traveled 40 seconds. He is moving only along the boundary, which means how much he will travel in 2 minutes, no? So 120 seconds, so because 120 140 seconds, how much will he move in 140 seconds? Use the unitary method here. 40 into 140 by 40, how much he has traveled? 140 meters. He has traveled 140 meters, which means first he has moved 40 meters, displacement is 0. Another 40, displacement 0. So 80 over. Then first of all, one path, okay, one complete path, one complete round takes how much distance here? One complete round is taking how much? 40 meters. How many rounds will he take for 140 meters? 140 by 40. Okay. 2 2s are 4, 2 7s are 14. 2 1s are 2 2s are 2 3s are 6. 2 5s are 10. 3.5 rounds, which means he has traveled first 3 rounds. He has traveled 3 rounds. For these 3 rounds, the displacement is 0. Then he has moved 0.5 rounds, which means he's over here. 0.5. Okay, he has moved 0.5 round extra, which means he is over here. Okay, which means 20 meters extra he has traveled, which means what is the displacement from initial to final point? This will be the displacement. So this is 90 degree. This will be root of 100 plus 100. How much will it be? 10 root 2. So what is the displacement here? Displacement is how much? 10 root 2 meters. Did you get the point? What is the step 1 here? Step 1. First you find distance, basically the length and path relation. Length and path relation, like how much, at what instant, how much, like at how much minutes or how much seconds, how much distance it traveled. Step 2, for they have given for 2 minutes 20 seconds, no? So for this 2 minutes 20 seconds, how much it traveled? Unitary method for timing. For 40 seconds it has traveled 40 meters. For this much duration, how much did it travel? 140 meters. Then step 3, you need to find out how many rounds for that path length. So if you see here 40, they have clearly mentioned it is moving along the boundary, which means 40 meters it has completed one complete round. So 140 meters, how many rounds? So these 3 steps we have used to solve this question. I hope this is clear now. Let's move on to the next question. This is a little level up question. Okay, this was there in the previous question was your NCERT question. This is a level up question now. Displacement of a person moving from A to B along a semicircular path of radius r is 100 meters. Okay, let us say this is a semicircular path like this. This is A, this is B. They have told that this displacement from A to B is given to us 100 meters. And this is a radius, let's say this is the radius r. What is the distance traveled by him? Distance is basically what? This is a distance. Okay, this is a distance. Simple it is, right? Pi r. Now diameter. Now if you see from here to here, AB is how much? 100, which means 2r is 100. What is r? R is 50, which means distance is how much here? Distance is simply 50 pi. Is it simple? simple question, right? Okay, so thank you for watching my video. I hope distance displacement concept is crystal clear. We will be bringing uniform motion, non-uniform motion concept in the next video. Along with that, we will be doing average speed, average velocity also in the very next video. So I hope the concepts are getting clear for you. I will upload questions, DPP questions file after explaining the next video, because both the concepts combinedly, usually the questions are asked. Okay, so this video, I hope you have understood properly. Read NCERT after this. Okay, and if you have any good reference book, you can solve few questions related to these concepts from those books. Okay, so in the next video, after uploading next video, I'll be uploading the DPP, so that both the concepts you can combine and you can solve the questions. Okay, thank you all for watching. If you like my video, you can share it with your friends, and you can subscribe, so that it is a kind of support that you'll be giving me. Okay, thank you, bye.